what is the differential equation? Plus d plus equal to right. Say only thing that one order is more. Again, assume VOT to be assumed as right. It's okay. So what is dVOT by dt? It is minus b omega sin omega t plus a omega cos omega t, and then one more, that is d2 VOT upon dt square is equal to is minus b omega square cos omega t minus a omega square. Is it right? Is it fine? It's okay. So it is that whether d2 VOT upon dt square is equal to omega square VOT. Is it right? Correct? This is actually omega square VOT. Minus omega square VOT, right? So what do we get? What is the equation? So we can make a small change, minus omega VOT plus VOT plus dVOT by dt equal to V. Is it right? So if you look at this, b cos omega t plus a sin omega t is there, and minus omega square is multiplier. So this is minus omega square, sorry. So it is 1 minus omega square VOT plus this. So what we can simplify? One minus omega square into VOT is b cos omega t plus a sin omega t plus dVOT by dt. What is dVOT by dt? Minus b omega sin omega t plus, so what while writing I write like this, cos one below other, minus b omega sin omega t is equal to v. What is v in t? Cos omega. So you just match the coefficients. For cos, on left hand side 1 minus omega square b plus a omega must be equal to 1. And for sin, 1 minus omega square a minus b omega must be equal to 0. So from that you should be able to calculate a and b. Is it right, Lakshana? Now calculation part remains a very, what we can say, high school scholarship level problem, not beyond that. Is it right? Now these are passive circuits, and in passive circuits you find that the gain is always less than 1, because if input magnitude is 1, in the output you get the expression, when you club cos and sin terms, something upon under root something, and under root something is always more than 1 or at the max equal to 1. So the ratio is always less than 1. Now I am giving you a very interesting problem. I am sure that it is not so easy for you to solve. I expect that you do it. I will give you a hint also. While looking, the circuit remains, it looks like very simple. Actually, constructing differential equations is a very difficult task. Now for this circuit, this is a separate assignment. It is about two parts. Same circuit I draw again. The two tasks. Number one, find differential equation for this circuit. For that, both are probably same. This is question 1A. For that, you do this will solve in the video classroom. And question 1B. So for both A and B, find out differential equation. V in T, in terms of this is V in T actually. And in first problem, differential equation is formed. Derive the expression for VOT if switches is equal to T equal to 0 and both capacitors discharge at T initially at T equal to 0. This is question A, part A. And for this, find VOT if here VOT becomes a function of omega. And for that, initial condition is not required to mention right now. This is a very complex problem. Question 1A and question 1A and 1B. And hint I will give, you will surprised to know that this output becomes more than 1 for some time. This output is a passive circuit. There is no element like amplifier or adder. Despite being passive circuit, output becomes more than input for some time. That is the VOT, output becomes more than 1 and then comes to 1. And here also, gain becomes more than 1 for a peculiar frequency. Gain, what is the output? Input is this, so output has to be A cos omega t plus B sin omega t. That is effectively C cos omega t plus phi. That's what we get. An expression of C is such that for a peculiar omega, C becomes more than 1. Right? So I hope that you proceed, try to work on this and we will meet tomorrow. Attendance.